Let's continue to look at the case study from the previous video. And in this case study, we were just going to take our big file of Alabama weather station data, and we were going to move all of that, copy all of that into an array of records or array of structures. So we declared the array as you normally would. We have the name of the array, and we have the size of the array in square brackets, where that constant is 3200, and the type of that array is called weather data, and the weather data is a structure. So we looked at that in the previous video, but here it is again. So we are going to make an array of these structures. In the previous video, we opened up the data file, and we read all the data into that array of structures. So this array is actually 3,200 approximately, or has approximately 3,200 elements in the array, so it's big. And each one of those is a complex item. Okay, it's a structure. So within each index of that array, we have all of those things. 1, 2, 3, we have 11 things stored in each element of that array, and they are of different types. We have a string, a date, which is 3 unsigned integers, and then we have some doubles. So we have an array of structures, and within that array, we have a collection of data in each one of those indices. So that's quite a complex structure we've created. Now that we've done that, then let's use that array of structures in order to do some operations. So what we will do is, let's scroll down to this part of the program. We left off last time right there where we were printing out some records, only the first 10. We printed out the first 10 records from this array of structures, so we didn't get into it very far at all. But now let's use that array of structures. So we are going to get the data for any station on any date. Now we know that the date range is only March of 2018, but we'll stick within the month of March there, but we'll pick out any day that we want, and we'll pick out any station that we want, and we'll write a function to print out the data for that station on that date. The way we'll get started with this is we just have a string type here that I've declared called name station, and we've got the month, the day, and the year. That's already declared up at the top. So we will prompt ourselves or the user, to enter the station and the date, and then we'll just use an ordinary CN statement. So we'll read in the name of the station, and we'll read in the date in the month, day, and year fashion that we're accustomed to. And then just to be sure we typed everything in correctly, then we'll just print that data back out to the screen. Okay, so we'll print out the name of the station and the date. All right, now given that, what we want to do is to go get the data for that station on that day. To do that, I'm going to write a function. Then we'll call the function here. Now you see, coming up, we're going to do a sort, but first things first, let's take care of this particular item that we want to do, this particular function. Now, let's scroll down where functions are, and you'll see that I've got a commit function GetRecord. So that's the function that I want to write. So let's begin to do that. Let's put the code in here for the function. Now, in order to search through the structure, what kind of data are we going to have to pass into the function? Well, we know we're going to pass in our Alabama stations array. We know we're going to pass in that entire array, and then we're going to pass in some information that allows us to search through that array. And that is the name of the station and the date. So all those things get passed to the function. So let's write the first line of our function to handle that. So I'll paste in the first line of our function here, and let's take a look at it. It's pretty long. The name of the function is GetRecord, because we are going to get a particular record for a particular station on a particular date. That's what we're going to do. In fact, we probably might want to make that plural to get records, because I would expect that the station may have several records on that day, but it's okay. We'll just keep the name GetRecord for now. It is a type void, which means the function isn't going to return anything. So that's just a choice that I made. I'm going to allow the function itself to print out the data. And that's just a judgment call. We could have returned the information to the main program and let the main program print it, but I'm choosing to let the function print it. It tends to work a little bit better this time. Now let's look at the formal parameters inside the function. And like I said, we have quite a few. We know that we are going to pass in our array of structures. So I've got a type weather data here, and I've got a formal parameter, local parameter called record, and it has the double brackets indicating that that is an array. So this is going to accept the array of structures that I pass in. Now, I am going to search on the name, so I need to have the name of the station that we typed in when we prepared to call the function. And I'm also going to need the date. Okay, so we got the date here, okay, the month, the day, and the year. Then I'm also going to pass in how large this array is. See, the brackets are empty. So I am going to pass in the number of elements which represent the size of the array. So we have all those parameters coming into the function. Now let's work through the body of code that we're going to need. So let's start with this part of the function. And I'm going to declare just some local variables here. Unsigned integer k is 0 and position 0. And I've got a Boolean variable called found that I'll just set to false to begin with. Then I realize now that I do need to go through the entire array, so I'm just going to set up a for loop for that. So k will start at index 0, and it keeps going till we get to the number of elements -1, and then just k++. So this is just a typical for loop that we would use to go through all the elements of any type array. Now, as we go through, we need to try to find these things. We need to try to find the name, and once we have found the name, we need to see if that matches up with the date that we have here. So we have to include now some tests to allow us to locate this station name that's being passed in. All right, so let's add code for that. So let's put that here. And I've got the beginning of the for loop. So I've got the curly brace starting with the for loop. Let's put the closing curly brace in as well, just so it looks better and that I don't forget it later. We have more stuff to go in the for loop, but I will go ahead and put the closing curly brace here. Now, there are different ways that we could go about looking for the name. So we are going to go through this loop, right? We're going to pass in the array, the complete array of 3,000 plus data records. And we're going to loop through them here. I am going to use this find operation to find the name that we're looking for. Okay, that's the name that comes in here. So we could type in a name like Decatur, and we would want to look into the station name part of the structure to see if it matches. So this is a pretty long statement right there. It has a lot going on. So let's look at it. The formal parameter is called record. It will take on all the Alabama weather station elements of the entire array. Okay, so we have to index into it. So we'll start at index 0, and we will look at the station name, or we'll access that particular field of the structure using the dot. So we'll start at record 0, the station name part of the structure, and we'll use the find operation to see if we match the name that we're passing in. So this station name is going to be, start with the first station name in our data file, and it goes all the way through. So eventually in there somewhere, we hope that we're going to find the station name that matches the S name that we're passing in. Okay, so I'm just using find for that. So I'm using the find operation to search for the name that we type in this field here. If it finds it, then we're good to go. If we do find it, then we will get a position that is a pretty small value. Because, the station name, worst case, the station name is 50 characters long. And our test, if we do not find something, this n positive number is a really huge value. So if we don't find it, then we will go inside we'll go further into the for loop. So if the position is not equal to that huge number, that means we've found it. Okay, so now we can start to process it. So we can add some additional code below the if statement. Now let's look at some of that. So let's put the code for the if statement below the if statement. That's where it should go. Then I've got a pretty long line here. In order to get the date correctly, we have to, first of all, pass this test. Okay, so the first test is we need to find the name of the station. So once we find it, then we will be inside this if statement and we'll do this code here. That code is going to check the date to see if it matches the date that we entered. So now let's scroll along and look at this comparison. We just need to access the month and the day and the year of the data record. Okay, so we have within each data record, we have that timestamp variable, and the timestamp variable has the three elements, the year and the day and the month. So we are comparing these. Okay, we typed in the month and the day and the year right before we called the function. Okay, so we typed that in up here. And that's what we're going to use when we call the function. We have to make sure that what we typed in matches what's in the data record. So that's what we're doing here. So we are going to test to see is the month that's stored in the current record of our array, if that month is equal to the month we type in, and the day that we have in the current record, that element of the array, is the same thing as the day we typed in. And finally, if the year that shows up in this record as part of the timestamp, if that's equal to the year we typed in, if all three of those are true, then we have found what we're looking for. So I'm going to set the variable found equal to true, and I'm going to print to the screen that we did find it. Hey, we found the data record. Then I'm going to call print record directly from here. So we saw previously that the print record function, it just prints out all the data that's in a particular record. So that's what we need to do inside our GetRecord function. We just look first to see if we can find the station name. If we find it, then we compare the date that goes with that record with the date that we type in. And if that's true, then we will print out the data for that station on that date. So that's what this function does. Now, it's possible we didn't find it anywhere, so we need to allot for that as well. Okay, this if statement, that might come up false. We may not have a data record for that station on this date. So in that case, we do need to provide some kind of output. So let's write out a message to that effect. Now, where do I want to put the code for that? Well, let's see, the for loop that we have here, that's searching through the array of structures looking for the name and the date. Okay, so this whole loop is looking for that. So it may find it, it might not. If it doesn't find it, then we want to put the code for the error message outside of the for loop. So I'll paste that in here. And that's where this found variable shows up. Okay, if I do find it, then found is set to true inside the loop, and we print out the data record. If we do not find it, if that if statement is false the whole time through, all the way through the array, then this will never happen, and found will remain as false. So if we did not find it, if not found, then that means found remains false. We'll just print out there's no data from that station, and we'll print out the name, and we'll print out the date. Actually, we won't print out the date. We'll just print out that little statement there. We'll say, hey, we didn't have any data for that station on that date. Then the function returns. So that's what the function does. Let's take out some extra code. Now, we need to finish up with our necessary items for the function. So we need to get the prototype. So I'm going to, it's a long line. So I'll copy the line and I'll scroll up, and that's a long way to scroll too. So we'll go back to the top of this function, and with the function prototypes, I'll paste this here and we'll add the semicolon. And now we're good to go. Let's call the function. So let's scroll back down to the bottom where we typed in that information. All right, so we typed in the name of the station, the month, the day, and the year, so we just need to call the function right there. So let's put our call to the function here. So I'll paste it in. And here we're sending in all the variables. So we call GetRecord, we send it in the array of structures, we send the name of the station we're looking for, we send in the date that we're looking for, and we send in how big the array is over here. Array stations, Alabama stations, it is that big, or as you may recall, it's 3,200. Then the function does its thing and it prints out the data, so we don't really have anything to do when the function returns. All right, now let's move our system pause down here and run the program. So I'll cut it from there and we'll place it down here. And we'll do this part first before we go and do any sorting that's coming up next. So now I'm going to compile the program and run it. Now the program's running, so let's bring over the window. And the information on the screen is from the for loop that we use to print out the first 10 records. So you can see that data is showing up. And again, the first record is from the 1st of March, and the last one is from the 10th. So we did print out 10 of the records that we stored into that array of structures. Now we are being prompted to enter the station and a date. Okay, well, I'm going to type something in that, really we should have data for it. And also I know that the names of the weather stations are uppercase. So I'm going to type in Athens. And the date, well, it needs to be March. Okay, so let's do 3/11, and the year is 2018. That's all we have data for. And then I'll enter that. And we get the output. So it says, hey, the station Athens has been found. And then we get the data that belong to that station. Okay, so we have the ID, and here's the station name. Yep, sure enough, Athens, Alabama, U.S. And here's the date that we looked for. So we found it, 3/11/2018. And then we have these data items, these 8 items of data that were pulled out of the data record, giving us the precipitation and the Tmax and Tmin, which is all we're concerned about right now. So the function apparently works. So let's stop the program. And now let's move on to something else. Let's look at the function one more time. And you can see that we're passing in this array, and the array contains it contains an array of complete data records. So each one of these elements is one complete record, one full line of data from that data file. So we have all of those things together as a unit passed into the function, and that makes it easy for us to process that data. Moving on, let's try to do another function. This one, there's a comment, sort the records by high temperatures. How can we do that? Well, we want to look at the Tmax values. That seems apparent. So that's what we want to try to sort out. And how do we go about doing that? One thing that we know is that we do have a couple of sorting algorithms. So in earlier videos, we looked at a bubble sort and we looked at a selection sort. So maybe we can use those. And we know the selection sort is a better one to choose. So let's try to use our selection sort to solve this part of the problem. Now I'm going to scroll down to the bottom of the program where the functions are, and I want to show you the selection sort. Now I just copied and pasted the selection sort that we did in a previous video when we were just sorting an array filled with integers. So here was the selection sort, and you can see we've got the array in. It's just a type integer, and it has that many elements, and I haven't made any changes yet. So all of this code is just exactly the same thing that we did earlier when we were sorting an array of integers. How can I modify this now so that I can use it in this array of structures? Well, how can we do that? Well, let's see. Certainly, this is going to need to change, right? The thing that we're passing in is not going to be an integer anymore. It's going to be our weather data structure. So that's one thing that we will need to change. We'll need to change that type. So let's go ahead and do that part of it. So I'm just going to, I'll copy and paste again. So let's change this integer to weather data. So now the type of the array is the structure of weather data. Okay, so this entire array will contain weather data elements. Now, the number that we have is still the number that we have. Okay, so we still need to know how big the array is, and that isn't going to change. Now, what about this part? All right, well, one thing we see is we have array n and we have the variable hold. Okay, so array n is now of type weather data, but the the variable hold is still an integer. Okay, so we have that up here, so we need to change that. So let's take out the variable hold from the integer declaration, and we need to declare it to be weather data as well. So let's just put that here. So now we have hold is declared the correct type, weather data. So that was necessary when I was saving one of the array elements into the temporary variable hold so we could do the exchange. And those have to be the same type, of course. So now array n, that's type weather data, and hold is also type weather data. So we can do all of those operations here, which just exchanges one element with another in the array. That's what we're doing with the sorting part of it. The other thing that's wrong is now these arrays are arrays of structures. So they're not just simple integers anymore. So we can't compare the whole thing. We can't look at the entire array and say one is less than the other. I mean, what are you talking about? Are we talking about the name? Are we talking about the date? We have to specify the thing that we are comparing in more detail. So we are going to be looking to sort the array in terms of the highest temperature. So we need to extract that and put that in here as part of this if statement. So to do that, we need to use the dot notation. So we do dot. And since this shows up nice and neatly for us here, we can just pick Tmax right there. And the same thing over here. We're still using array n, but we're not specifying which element of the array, which we do have to do. So we'll put the dot there, and we'll select the Tmax over here as well, because that's what we want to compare. We want to compare the Tmax values with each other, and the one that has, the smallest index and the one that we find here, then we just exchange them down here. So by doing those small changes, then we can reuse our selection sort, and it will sort our weather data according to the high temperature, Tmax. That's all there is to it. Now, let's go ahead and do this, and there's one more thing. Look at this comparison. Okay, that's a less than. So when we sorted the integers, we sorted them in ascending order. Okay, we had the smallest one at the top and the largest one at the bottom. In this case, what we'd really like to do is to sort them in descending order. If we want to get the hottest days, okay, the hottest records, the records with the highest temperatures, then we want to see those first. So if we just reverse that and we make it a greater than sign, not a dot, a greater than sign, then it will sort it in descending order. So this will give us the hottest temperature in index 0, and then the temperatures will descend from there to the lowest value that would be Tmax for the entire month. Wow. So we had to make a few changes then, but otherwise this selection sort should work just fine for us. Now let's take the first line and create the prototype. So I'll copy and I'll scroll and I'll paste. So let's put that in here right before main. So now we have our selection sort for Tmax. Then all we need to do is call it. So let's scroll back down near the end of the program. And where are we? Okay, here we go. Sort the records by high temperatures. Okay, we need to call our selection sort then, don't we? So let's put the line of code in to do that. So that's just a call to the function. So we call selection sort, and it only needs two things. It needs the array that we're sorting, and it needs to know how big it is. So I'm sending in this constant, which is 3200. Now that will do the sorting. When it's finished sorting, then we should have the records with the highest temperature at the top, the low order indices. So now let's print those out. So here we just have another little for loop. So we're going to print out the top 10 high temperatures, and we'll just print out all the other data that go with it. Okay, so this just our simple for loop, okay, goes 0 to 9, and we'll call our print record function, and we'll send it in the indices 0 through 9, and we'll print out those records, and that will end our program. Okay, so let's compile the program and run it. Okay, now we have the results, so let's move those over. And I've already entered some data to get down to the end of the program where we are interested. Now, here we are at the sort. So the sort function prints out how many element exchanges we had. Okay, so that's roughly the same size as the array. And then we are printing out the top 10 temperatures that we found. So let's look at those temperatures. So here is Tmax, that's 86. And we did print out the top 10 of these. So we had 86, then we had 84. Okay, the next one, here's another 84. And we keep going down. There's another 84. And another 84. And it looks like 84 was popular on that day, on the 18th of March. Okay, here's one, the 25th, another 84. And here's another 84 on the 25th. From a different location. And as we keep scrolling, then we get all those numbers. So there were quite a few weather stations that recorded in 84, but the hottest one, we can go back to the top, and we see that the hottest one was 86. So these are in descending order, even though we have a lot of stations that reported in 84. So they are sorted in descending order by temperature. So the function works. How about that? Okay, so if we wanted to, of course, we could expand this and we could print out as many of these as we could tolerate, and we could see more of what those values are. All right, so that shows you then that we can use our sorting function, and we can sort a particular field within our array of structures. So in this case, we were sorting, let's get back down to the sort. Okay, in this case, we were sorting the Tmax value, and we could pick any value that we want. If we wanted to sort by the minimum values, we could do that. If we wanted to sort by the precipitation values, we could do that as well. So, in fact, before we end this, let's do that. Let's sort the precipitation values. Let's find the stations that recorded the most rain. So let's do one more run through this. Okay, so I'll stop that. And let's just go in and let's change the Tmax values to the PRCP values. Okay, PRCP, precipitation. And we'll look at the precipitation field over here, PRCP. So now this is going to, what's it going to do? It's going to sort the precipitation element of our structure instead of the Tmax structure. So that's all we needed to do. Then when we get back and we print out the stations, we print all the data out anyway. Okay, so this now is going to give us the top 10 precip values. Let's do PRCP to make that correct. All right, so now let's compile the program and run it this time. Now we can look at the output. So here we are. This is the sort. So the sort produced that line of code telling us how many exchanges it did. And this time we sorted it according to the precipitation. So we should have the maximum here. Okay, so we're descending, sorting by descending order, precip. So we had 3.2 on the first from Bridgeport. Then the next one is 2.9. That's on the 11th from Selma. Okay, then the next one, 2.81. And that was on the 20th from Heflin. So you get the idea. Okay, now these records are sorted according to the amount of precipitation, 2.57, 2.55. So they are in descending order, 2.4, 2.4 again. And at the end, our last one, we had 2.08. So out of our top 10 stations, recording the most precipitation, then the range was 3 something to 2.08. And we get the complete data record for that station on that date. Okay, so what was it, 2.08? It was the 10th one and The top one was 3.2, I think. Yeah. All right. So now we've sorted these according to the precipitation values in descending order. So this illustrates that if you store the data that you have in a structure, then you have a lot of versatility as to what you can do with it. If we didn't do it this way, then one way that we could do it would be to have an array for each of those 11 things. That would be 11 separate arrays, and that would be a lot more cumbersome to deal with. If we needed all that data, then we'd end up passing in, say, all 11 of those arrays into functions in order to do some processing for us. So by using structures, it makes this much more easy to do. It keeps all the data in a unit, and we can pass the data as a unit. And with these arrays, we read in that entire file. We put the entire file into a single one-dimensional array. How about that? Okay, that's a pretty good case study. There's a lot of detail in this one. You may need to look back through this a couple of times to pick up all the little details, but it works. And you now have a great deal of programming power at your disposal in order to work with these arrays of structures. Okay, that's it for now. We'll end the video here.